for the kind introduction. Can you see my screen and hear me well? All good?
Yes, perfect.
Can we start? Okay, awesome. Thanks everyone to take the time to attend this webinar. I'm Jacopo. I'm the lead data scientist of Coveo. Coveo is a North American company providing search, recommendation, and other AI services to hundreds of clients, including several Fortune 500 companies. The work we're presenting today is a joint work between me and my esteemed colleague, Christine, which couldn't be here. So unfortunately, you're stuck with me today. And we're gonna discuss how to try and measure the value of your AI initiative, in particular search related, information retrieval related, without A/B testing, like in case where A/B testing is not possible. To kind of get some color to the problem, for those of you who are not super familiar with the problem of attribution in e-commerce, it's a very simple question. Let's take Bob here. Bobby lands on a sport apparel website. He starts searching for NBA shoes. He got some results. You see some mixed results. He clicks on the shoes on the top left. Then he goes back to the listing page. He walks through other type of basketball shoes. And in the very end, you see here, step number 7, he buys a pair of shoes, which is a basketball shoes, but it's not exactly the one that the search engine would propose in the first place. So the question that we have is this purchase a win for the search engine? Think about, I don't know, the marketing manager of the sport apparel website. Should he be happy of the investment that he made on search, or is this search actually attributable to something else? If you look at what industry standard tools do, for example, Google Analytics from Google, Omniture from Adobe, or what other recommendation company do, Rich Relevance is an example, what they used to somehow measure the importance of the search engine or the recommendation for the purchase is what we call the presence heuristics, which is very simple. It just means that search is responsible for the purchase since there was a search event in the same session as the conversion. But as we can see here, this is the case of Alice. Well, the presence heuristic may not be exactly a good guide to tell you how much search or recommendation are important. Let's take Alice, for example. She goes to the same website. She searches for NBA shoes, exactly same result. She clicks on the same product. But then she completely changed her mind and she browsed to the tennis racket session. She browsed a bunch of rackets and then she buys, again, step number 7, a tennis racket. And so the question for us is, was the search engine interaction in step number 2 somehow important for Alice to buy number 7? And the obvious answer is no, right? This is a search, but the search event is completely unrelated to actually Alice's buying at the very end. So the first question we're going to answer today is that what does it mean for a purchase to be attributed to a search interaction? What are the conditions under which we can actually say truthfully that search was important for the conversion to happen? There's a second question that we're going to tackle today, and I think is best understood as a comparison with what happens in physical retails, and in particular, the importance of having good salesmen in your shop. Let's take Ed, for example. So Ed walked into a physical shop this time. He has a very specific need. He says to sales assistant number 8, I want a Nike t-shirt. It's going to be green, and it needs to be a medium size. And of course, assistant A, it just gets you the green t-shirt, and Ed buys it. Awesome. Which is very different from the case of Anne. Like Anne goes into the same physical shop and she's kind of more undecided. She was like, I want something nice for a party. She's a much more vague intention. But assistant B is a very good salesman and it turns that vague intention to a lot of purchases. In particular, Anne leaves the shop after buying a dress, a pair of earrings, and a pair of shoes. Of course, in both cases, assistant A and assistant B did their job. Nobody's questioned that. But there's a deeper sense in which what we want is really assistant B's more than assistant A, meaning that we want somebody that can turn a vague intention to act into a purchase. Assistant A, yes, he did his job, but he didn't go over and beyond to succeed. Assistant B was presented with a much harder case, and still he was able to actually produce the conversion for the physical shop. So the second question that we can see here is that, well, attribution comes in degree, right? Both assistants were very instrumental in actually complete the purchase. But of course, in one case, the assistant played a major role. In the other case, the assistant was mostly doing exactly what the client wanted. So our second question is, given that attribution comes in degree, how can we distinguish in between great impact and okay impact? So today's goal is to gonna try and find a way to measure attribution in an e-commerce shop, but we're gonna see this is obviously goes more general than that as a causal effect, which means we're gonna try and distinguish when actually what happens between the shopper and the machine is a cause, not just a correlation or a predictor of the final consumer choice. No current tool really helps you with that. And in fact, as you see, if you buy Google Analytics or Adobe Omniture or whatever, most of the industry knowledge, even in a fairly advanced field like e-commerce, treats attribution in a way that is still honestly a bit heuristic-based and anecdotal. What we're gonna do, we're gonna use AI to basically assess the impact of AI. Why do we care? Well, we care because if we don't really know why people buy on our website or what people really want to do on our website, we're going to make very bad decisions for our digital strategy. For example, if we don't know how much our search engine or how much our recommendation are bringing in terms of revenue, we don't know if we need to change provider or to add more people, or instead to somehow change the UX to reflect what users like to do. It helps because for people like me that builds AI model, having a way to measure exactly how much search is important is very good for us within the organization, as we can communicate the ROI of this investment. And we can communicate also across organization, meaning that we can go to our clients, our customer, our partner and say, hey, we know because we measured it in a non-anecdotal way, how good our search is. And of course, it's gonna help us build better models. As you probably know very well, when people build machine learning models, they typically optimize for something. But the question here is that if you cannot really optimize for revenues, if you don't know which event in the past are actually events in which search will actually causing increase in revenue. So if we have a good understanding of which sessions are actually sessions in which people buy because of what they search, this is very good for the final optimization problem. So to understand why everything is wrong with, let's call it the Google Analytics way, we're going to take a step back and we're going to go into a field that has perfected the concept of understanding causal relationship, which is drugs. So how do we know that aspirin works? Let's take this example. So Alice is having a headache and then she takes some aspirin. After taking some aspirin, she eat a plate of spaghetti because she really likes spaghetti. And in an hour or so, the headache is actually gone away. Like this is probably a story that's familiar to many of you, especially if you are Italian and like spaghetti like I do. So the question here is, does aspirin remove the headache? So is aspirin responsible for removing the headache? And if we ask Google Analytics, yes, of course, right? Because Alice took the pill and then she felt better. But unfortunately, if you apply the same kind of reasoning, well, it turns out that spaghetti also helped removing the headache. Why? Because of the same reason. If you ask Google Analytics, the spaghetti was actually part of what Alice did before feeling better. So eating spaghetti is actually good for your headache. There are many good things that I can say about eating spaghetti, especially because I'm Italian, but there's obviously no proof that spaghetti actually cure headaches, while we have consistent proof that aspirin remove headache. So how do we came up with those proofs? Like, how do we came up with a better protocol to measure that? Well, in the field of drugs, we typically have what we call randomized control trial, which is the standard for causal detection. What happens is that you have two people that are basically almost exactly alike in all important respect, Alice and Anne in this case. They go to two doctors, in this case, Dr. House, and the doctor gives to Alice aspirin and gives sugar to Anne. And then we're going to ask Alice and Anne in an hour if the headache is actually gone or not. It turns out that Alice aspirin cured headache, and it turns out that sugar doesn't do anything for the headache. And that's the way in which we know that aspirin cures headache, and then sugar or spaghetti or whatever else do not cure headache. So all methods for discovering causality in other fields, trying to answer like a typical question, which is a counterfactual question. And the question is, if Alice had not taken the aspirin, would she still have the headache? The conundrum for us is that in the real world, the world we live in, Alice actually did take the aspirin. So our entire protocol is designed to find a way, creative ways in this case, to imagine what did not happen but could have happened. This is a very crucial point that we're going to exploit later on. So now that we understand causality in drugs, let's go back to commerce. So let's ask the same causal question in this case of search in e-commerce. So to understand if search actually is important for your conversion, for the money you make on a website, in the same counterfactual vein than the aspirin question. So if Bob had not searched on that sport apparel website, would he still have bought the same pair of shoes? And of course, the naive protocol we can set up is exactly copying the drug case, right? We're going to do a randomized control trial. So we're going to take a user like Bob, we're going to show him a search engine, we're going to add in search for NBA shoes, and we're going to observe what he's actually buying. And then we're going to take ad, and we're going to show ad a website that has no search bar at all, and then we're going to observe if ad is buying something or not. This is the equivalent of the aspirin with Dr. House before. What is the problem with this line of thinking for search engine or for very important part of your UX? That you cannot really switch off a search box entirely, right? Imagine if you go on Amazon and Amazon decide to allocate 5% of the traffic, which is millions and millions of people, to a website without no search bar, right? Sure, it may be good as an experiment protocol, but that's going to cost millions of tens of millions or hundreds of millions in lost revenues. So a very important and crucial point about the digital world is that while in theory, randomized control trials are the best way to assess causality, there are many, many cases in which what are normally called A/B tests in the digital world cannot be performed. And search is one of them, and one of the most important, as everybody expects when they go on a website, on an e-commerce, to find a search bar. Just removing the search bar for experimental purposes is just not going to fly with our business and management objective. So let's go back to the real problem we're trying to solve here, which is the counterfactual question. So if Bob had not searched on the website, would he still have bought the pair of shoes? So what we need to do here to assess attribution is find a way to create a reality in which Bob did not actually search. And then we're going to go and check in that reality if that shopper buys or not. And that's why our method is called shopping in the multiverse. Consider, for example, these two shopping sessions. So the shopping session on the top is Alice, is the orange section, as it would actually happen in the real world. So Alice was browsing some shoe section, was looking at some particular product. Here's the basketball shoes. She's going to search for basketball shoes. She's going to click on a basketball shoe. She's going to buy. This is what actually happened. Again, we can't really change what happened. But to answer the counterfactual question, we need to be able to see a word which is exactly like the one in orange, but in that word. So use the blue word. If you see the blue word at the bottom, that's a simulated word, which means that we're going to simulate a word that starts off in the same way. It's a session which is exactly the same as the orange one. So browsing on shoe section and sees a detail. But then, when the dotted line, there's no more search interaction. So Alice Blue is not the real Alice, it's a simulated Alice, and we're going to follow her into a session when no search is allowed. Of course, since this is like an imaginary session, and we're going to see how to create that in a moment, we're not causing any damage to our business, right? So we're trying basically to do an A/B test without having to switch off the search engine on a website. So we're going to try to do causal attribution without actually damaging our user experience. So if the only thing we can observe is Alice Orange, now the question is like, how can we know what Alice Blue, the imaginary one, will do in this alternative world? So the concept is pretty clear, or should be pretty clear by now. We have a real session when a user searched and they bought something, and we're going to ask if the user would have bought that anyway without the search. To answer that, we're going to create an alternative session when the user is behaving exactly like the real user up until the point of search, and then we're going to see in that session what this imaginary user is doing. How do we do that? Well, to do that, we need a generative browsing model, which means we need to have some sort of like a factory that instead of producing, cars, it produces alternative session. It produces sessions that didn't really happen in reality, but actually can happen, and they're a realistic model of how user behave. So we're going to use deep learning to actually generate alternative timelines to solve our problem. The way in which we're going to do that in particular takes advantage of what are called product embeddings. If you're familiar with word2vec, and word embeddings is a way for you to encode basically words like cars, dog, cats into a low dimensional space in such a way that words that are more similar will be closer into the space. For example, cat and dog will be closer to each other, and I don't know, the numbers 1 and the number 3 will be closer to each other, but in another part of the space. It turns out you can use the same trick on products in an e-commerce. So what you do is basically you can build a low dimension representation of the of products in a space, and you can then use this low dimensional representation to basically model the behavior of user. If you think that all these dots in this space you can see here in the image are products, when a user is browsing a website, is basically moving from one dot into the other. As you can see here, the products are color coded by their sport activity. For example, the violet are running products, the light blue are soccer products, and so on. And you can see here the algorithm is very good as basically clustering product by the sport activity. If you were to see in real time what Alice is doing, Alice is basically going from one of these dots, so from one of these products into another product. And by following Alice into this journey, we're basically able to create alternative timelines. This is an example of a person that's interested in sneakers. So she's actually browsing through a couple of sneakers. And by conceptualizing our products in this way, we can actually follow the journey of different users in different regions of that space. So how to create a multiverse? So again, we have the actual world, which is what actually happened in reality. And you have the user that actually was browsing on the shoe section, was searching for basketball shoes, was clicking on basketball shoes, and then is buying them. And then we have the multiverse, which is two alternative timelines that are created with our deep generative model. The first timeline, it's called W1, it's the blue one, is exactly the same as the real world, but the timeline diverges after the search event. If you see W1, in fact, you have the same like initial path, shoe section, basketball shoes, click, and then the rest of the session is actually simulated with our model. And W2, which is the green one, is a session that diverges from the actual world, so what actually happened in a session in the green, sorry, in the step before the search event. In fact, if you see that, the first event is in common to all three timelines, the shoe section browsing. And then in this case, the user doesn't really go and search, but it goes back to the running section, he starts browsing a bunch of stuff, and finally he buys something else. The crucial intuition here is that by seeing how these three alternative timelines ends, the real one and the two simulated one, we're gonna be able to assess if the search was actually really important or not. The cool thing about using product space is that we get for free some nice visualization out of it. So we can actually print in 2 dimensions. We can actually try to make sense, what we call geometrical intuitions. We can actually make sense of what happens on a plane when we represent our user in this way. So in this picture here, you can see the 3 points corresponding to the final step in all the 3 sessions that we saw before. So these are the session. So these are the 3 things at the end, the 3 products at the end of these sessions. And these are the 3 sessions in the product space. If you see here, you can see that in this session, the actual session ends up in a very similar portion of the product space as the simulated search session, as the blue one. While if for people that actually didn't search, so the green session, the end result of the timeline is actually very, very far from that, which makes us think, again, if we have to answer the question, what Bob would have done without searching? Well, the without searching part is this green dot here. As you can see, if Bob hadn't searched, it would end up very far in the product space from what actually happened. And this is a very good sign for our search strategy, because it means the search made actually a very big impact on the final outcome. So in a parallel universe without the search, the shopper ends up very far from alpha, which is a green point, while in a parallel universe with search, the shopper ends up very close to alpha, which is the orange point, which means that the search event actually was very instrumental in pointing the user to the part of the space that he was really interested in. So search, in this case, is very important. Of course, there's a bunch of different patterns that you can see while you observing hundreds and hundreds of thousands of e-commerce sessions like we did. And not all attribution, or not all cases are so straightforward as this particular case. Take, for example, this example. This is a real example. So somebody searched from Pegasus 35, which is a pair of Nike shoes. He clicks on the result. It goes on and browse the details of this pair of shoes. But then he actually had to cart and buy a pair of socks. Okay. So what happens when we build the multiverse chart for this irrelevant search event? Okay, I guess we can all agree that this is an irrelevant case, right? The user search for something as a pair of shoes, a very specific pair of shoes. He browses that, but then he goes off and buy completely something else. So the actual session, which is the orange one, which is what the user actually bought, is very far both from the simulated search session and from the actual event session. Just by looking at this plot compared to the previous one, you can see how different that looks like when something is irrelevant compared to when search is actually relevant to the purchase. Now let's do something that's trickier, which goes back to our first example with the salesman. So here's again another real session, product detail, searching from Lakers. The user clicks on the shirts, which is the same shirt that he was seeing before. Then he had them to the cart and then he buys them. So as far as semantics goes, we can all agree that search was actually doing a good job here. So the user was actually searching for Lakers stuff. He got Lakers thing and he actually bought something about the Lakers. So this is not the case as before. This search is clearly relevant somehow. But we can all agree that this is a much easier case than the basketball part. Why? Because at the end, the user is buying something he was already looking at, which means if we think again about the counterfactual test, that the user probably wouldn't bought it anyway. So search did a good job here, but this is kind of the first sales assistant we described. The user was so focused, was so precise in how he expressed his preferences that it's very easy for the search engine to satisfy that. If you look at the geometrical chart again, you can see a completely different pattern from the previous two. So here, all the three sessions, the actual one and the two simulated one, ends up to be and to end in the same part of the space, which is again tells us that this is somewhat a different causal attribution than the one we saw before. Again, attribution comes in degrees, and we're not saying here that search didn't do its job. We're saying here that search was less important than in other cases. You can see here is like on the left, the mild attribution case, the Lakers case, and on the right, the high attribution case, which is the basketball case. As you can see here, even by the naked eyes, it's very easy to distinguish between these two cases. So all of this theory and all of these charts and all of these pretty images are all nice and well, but the question is, does it really work? Well, too long did not do it. Yes, it actually kind of works. So we bench multiverse and three baseline to understand how it's behaving. So the three baselines are, one is Google Analytics, which is again the presence heuristics. As long as there's a search in a conversion session, we consider that as a full attribution for search. Then we train what we call a similarity model, which predict the relevancy based on the vector similarity between what the user has clicked after the search and the purchase. It's somehow like a simplified version of the product space idea. We're not trying to really gauge the counterfactual component of it. We're trying mostly to gauge how semantically related is the item that the user clicked on after a search and what he actually ends up buying. And finally, it's a very strict rule, which is the SKU match, which is also present in a bunch of commercial tools if you're familiar with what the industry is doing. And in this case, we're considering a search win. We're considering like a purchase to be attributable to search if and only if the same product that the user bought is actually the same product as what the user has clicked on after a search. How do we assess this? Is first through a synthetic dataset and then through a real dataset. Why a synthetic dataset? Well, there's no real labels in the real world about what causes what, right? So a typical trick from the literature in causal attribution is to build synthetic dataset. Synthetic dataset have been in such a way that we know by design if something influences something else because we built it that way. So what we did, we were using like a real product space and a real model to basically produce synthetic sessions that when we know when the search event is statistically related to the purchase event, and in other cases when the search event is completely relevant. And we're gonna check all of this model, and we're gonna measure how much of the session that we find are actually sessions for which the model predicts that the search was important. Of course, Google Analytics is always 100% because Google Analytics is the upper bound. Remember, Google Analytics tells you that as long as there's one search event, that purchase is attributable to search. So of course, in this session, they're all the same. And then we test similarity and multiverse and SKU match, they all give you around 50% of ratio, which means that if you take into account a slightly more sophisticated attribution strategy, the attribution of session to search actually is gonna drop considerably. And of course, since we have like synthetic label, we can actually measure the accuracy, and you can see here, both for similarity and for multiverse, we're well beyond 90%. Once we're kind of like sure that this method works on synthetic data, so we know that we're actually measuring something that matters, what we're gonna do is we're gonna apply this to real data, for which we don't have any real label. So the only thing we can do is to actually read off what is the percentage of search sessions that are gonna be judged as important. But all the statistical strength of our model comes from the synthetic data set. So in the real data, of course, again, Google Analytics, that 100% of search sessions are actually important for purchases, because again, Google Analytics is made up this way. But then if you go on similarity and multiverse, they give you like a very, very similar percentage, which is 75% approximately. SKU match is a very, very rigid rule. So when you apply it outside of synthetic data, it actually gets you a much, much lower attribution value. Like, we believe that SKU match is a good heuristic, but it's way too strict for real use cases. Because, for example, if you're searching for Lakers and you click on, I don't know, a pair of shirts, but then you're gonna buy the Lakers jersey, I think there's an argument to be made for the fact that the search was actually relevant, the search was actually important, but the SKU match strategy is gonna completely lose this kind of like similarity. Multiverse has an additional properties compared to all the other methods, which is not just a binary score, which is what we provide with the attribution table before in the benchmark that we just presented, but it's also able to provide you with a score. It means that the multiverse is actually able to tell you to put like this concept of attribution in degree on solid ground. If you see here, so we basically use the distance, like the cosine distance in the product space between the purchase, the session with purchase and search versus purchase and no search, and we compute a scores on the synthetic data. If you see here, these are the average of these scores for the synthetic data for which we know the actual importance of search. And you can see here, even by the naked eyes, you can totally see that this score changed dramatically between super relevant search, mild relevant search, and of course, irrelevant search. Which means that if you want to compute not just a binary score, which is what, again, Google Analytics and most tools do nowadays, but if you want to supplement a dashboard or your report with something that it's more fine-grained and more continuous in nature, you can totally do with the multiverse. So wrapping this up, so we presented what we call the multiverse method, and we proved that it's able to distinguish relevant from irrelevant search when it comes to conversion, which was our main goal and our first goal, to somehow make some like practical progress on top of what Omniture Google Analytics are doing today. We also saw that it's able to distinguish easy purchases from great shopping experience. So it's also able to not just tell you that something was actually bought because of some previous search event, but it's actually able to tell you when search has a crucial importance in the conversion and when search kind of some importance, but not too great. And of course, the cool thing about this is that if you can build a product space and you can build a deep generative model for your own shop, you can straightforward extend this, for example, to recommendation. So for example, instead of trying to see in a session what happens with timelines involving search events and simulated search event, you can try and do that with recommendation event. And of course, it's not written here, but it should be obvious. This method is actually applicable to any case of causal inference and causal attribution when you cannot really do A/B test, but you kind of have an underlying deep space that's with enough data to train a generative model for user behavior. Every time you can train like an accurate model for user behavior, you can actually reuse this intuition that causality is basically what happens in alternative timelines. The general gist for us, like for people like me that build search engine and information retrieval models and so on, is that when you take into account a more sophisticated version of attribution, a more sophisticated compared to Google Analytics, we estimate that 75% of conversion are actually attributable to search, which means that one search event out of 4 in your purchase list, in your purchase history, is actually not that important. Next step. So now that we learned all of this, where are we going with all this new information and this new model? Well, the first one is that a sophisticated approach to ROI and measurement of value. I think it's really highlight the importance of a uniform approach to AI services. We have like hundreds of clients. For some of them, we do search and recommendation. For some of them, we just do part of that. And one thing that we notice when we start socializing and kind of like extending this more sophisticated approach to measurement is that a single provider tends to be better from this perspective than multiple providers. Why? Because a single provider can somehow take everything that happens in all touch point, recommendation, search, category listing, and so on, and put it into a consistent strategy, a consistent AI strategy. So it's easier to debug, it's easier to handle, and it's easier to somehow measure the causal importance of that. So in this case, one provider seems to be better than a multitude of providers, one with a piece of the entire site experience. Of course, the second result is that preliminary results support the vision that search is slightly more important than recommendation, which means that while recommendations are known to be very important to the customer to buy stuff, search seems to be, from the point of view of causal attribution, so not from the point of view of correlation, even more important. Which means if you're building a website and it's an e-commerce website and you forecast to have like a lot of traffic, investing in search is really, really mandatory. Investing in good search is really important for the final business KPI. Of course, we just had 35 minutes, so we have to skip through a lot of technical details, but we also wanted to have this as a more conceptual and vision chat than just, the cold formulas and details. But if you want cold formulas and details, well, we have you covered. So what we presented here has also been presented at CIGAR, the top conference in the world for information retrieval last summer. The paper is called Shopping in the Multiverse, and the preprint is available for free in archive. And there are details there on how do we train the models, how do we build a synthetic data set, and so on. So we shared a lot of the tricks that actually went into building this nice chart and this nice presentation. We shared them into. If you want more, please don't hesitate to download the paper and reach out to us. Thanks so much. I'm happy to take any question now.
We have questions in Q&A section.
Yes, sir. So hi, turning on my camera. Sorry, I did it with the camera closed because my connection today is like a bit spotty, so I didn't want to ruin the experience. So first thing, the second question, which is, did we publish paper on this? Yes, we just covered that with the last slide, which hopefully you can still see. I don't know if you also see if I click on this. But yeah, we published one paper on that at CIGAR Ecom this year, and there's a lot of details on again what we did on the modeling side and like literature review and so on. The first question is, getting enough experience the only thing that stands in a way, by Peter, which I'm not super sure how to interpret. Can you elaborate on that, Peter? Maybe. Oh, okay, cool. Sorry, it was still okay. Thanks, Peter says. this question was the preview presenter, which makes sense because it's not really related to this talk. But yeah, it was still in my Q&A session, so I didn't know where it was when it was actually asked. If you have any other question, like feel free to ping me.